Here for class 12 chapter 2 function, this is part 3 of the function. Third question, f is a function from natural number to y and fx is equal to 4x square plus 12x plus 15 and y is equal to range f. Remember it that earlier I have told that if y is equal to range f means onto is already given. Now we have to show that f is invertible and we have to find f inverse. The first test for 1 function, if fx1 is equal to fx2, we have to prove that x1 is equal to x2. So let fx1 is equal to fx2. So fx1 for x1 square plus 12x1 plus 15. fx2 for x2 whole square plus 12x2 plus 15. Now 15 cancelled. Carry this to this side, 4 common, x square minus x1 square minus x2 square plus 12 x1 minus x2 is equal to 0. So again factorization, a plus b into a minus b is equal to 12, this 0. Now common x1 minus x2, so either this 0 or this 0, either this 0 or this 0, either this 0 or this 0. So taking this first two, now x1 minus x2 is equal to 0, so x1 is equal to x2, hence f is 1 1. Now to prove onto function, for onto we write y is equal to fx. So first of all for onto we write, since fx is equal to this, it means y is equal to fx should be written as y. For onto we have to follow this step, write y is equal to write y in place of fx. For fx I have written y. Then this, now 4x square left side, this is right side. Now carry y to this side. This is quadratic equation. This is quadratic equation in x square, where a is equal to 4, b is equal to 12 and c is equal to 15 minus y. Now since f is equal to f from n to n, so only positive value is taken. Here x is equal to plus minus b minus 12 plus minus root over b square 12 square minus 4 into c. Note that a is equal to 4, b is equal to 12 and c is equal to 15 minus y. So x is equal to this. So since natural number is given, so we never take negative value plus, minus 12 plus, only positive value is taken. So this 144 minus 16 y minus 96, 16 common, y minus 6 by 8 and this minus 12 from left went to right. First I have written this, then this by 8. Now on simplifying this we get 4 root this 8, 4 is cancelled, so this is x. Now since y is equal to range f, so f is onto already proved, no need to prove fx is equal to y. Next, since f is 1 1 and onto, so invertible or bijective, so first implies this and x is equal to f inverse, y is equal to this, answer is over. Fourth question, there are two problems, fx is equal to x plus 1 as well as x minus 1. So take for odd. First of all, taking this definition, since fx is equal to x minus 1, only take first. And this is for odd and this is for even. Two definitions are given. So in case 1, if fx1 is equal to fx2, if x1 is odd, x2 is odd, we follow the definition of odd. So this definition has been followed, this for odd. fx1 is equal to x1 plus 1, x1 plus 1, fx2 is equal to x2 plus 2, x1 cancelled. So x1 is equal to x2 when x1 x2 both are odd. Again, if x1 is equal to if fx1 is equal to fx2, then follow the even definition. x1 minus 1 is equal to x2 minus 1. 1 cancels, so x1 is equal to x2. Again, both are, when x1 x2 both are even. Now, know the very important definition of 1 function. You already know that when fx1 is equal to fx2, x1 is equal to x2. This is known to you. But there is one more definition. If x1 is not equal to x2, fx1 is not equal to fx2. Here there is one more case when x is odd and x1 is odd, x2 is even. So in this case, let fx1 is equal to fx2. Then x1 is odd. So fx1 will be x1 plus 1, x1 plus 1, x2 is even, so fx2 will be x2 minus 1. So we are not getting x1, we are getting 2 is equal to x2 minus x1. Hence, since x1 is not equal to x2, this definition, x1 is not equal to x2 because x1 has been taken as odd, x2 has been taken as even. So not equal, then fx1 is not equal to fx2. Hence again we are getting the function is 1, 1. If you are feeling any difficulty, you can remove this case 3. But 2 cases must be taken. Now for onto function, let x is odd. Let x is odd, then fx is equal to x plus 1. And write fx is equal to y. Y is equal to x plus 1. So x plus 1 is equal to y. So x plus 1 is equal to y, hence x is equal to y minus 1 first. In the same way, when x is even, fx is equal to x minus 1, y is equal to x minus 1, so x minus 1 is equal to y. So x is equal to this. The first and second are important. Now for onto we prove fx is equal to y. Here also we prove fx is equal to y. Since fx is equal to x plus 1 for odd x plus 1, so f kuch is equal to kuch plus 1, so f y minus 1 is equal to y minus 1 plus 1, 1 cancel, is equal to y, hence on 2. Here also fx is equal to y plus 1. Now f kuch for even, kuch minus 1. So f kuch is equal to kuch minus 1, so f y plus 1 is equal to y plus 1 minus 1, 1 cancel y. Hence again 1 on 2. Now on 2, so x is equal to y minus 1, x is equal to y plus 1. X is equal to f inverse y. Or here also x is equal to f inverse y. So for x odd inverse function we have got. Again for x odd we have got inverse function over. Question number 5. It is just like question number 4 discussed earlier. Here also in place of natural, here is w to w, whole number to whole number. Fn is equal to n minus 1, n plus 1 when n is odd, n is even. Almost same problem. If you are feeling problem with n, then let n is equal to x. After that exactly follow the steps of question number 4. और if you are not interested in writing n, fn, अगर n को x मानोगे तो fx is equal to x minus 1 by x plus 1 है. क्वेश्चन नंबर 4 के तरह 5 है, लेकिन ये n फॉर्म में दिया हुआ. दिस इज वेरी इंपॉर्टेंट क्वेश्चन. नाउ if you are interested in doing the work with n, then if n is odd, fn will be n minus 1. If fn1 is equal to fn2, then for odd, n1 minus 1 is equal to n2 minus 1, 1 cancel, n1 is equal to n2. If n is even, then fn is equal to n plus 1. So if fn1 is equal to fn2, then n1 plus 1 is equal to 1 cancel, n1 is equal to n2. So f is 1 1 1 1. If you are interested in third case, otherwise if you are feeling problem, you can remove third case. If n is odd, n1 is odd, n2 is even, then fn1 is equal to fn2 implies n1 minus 1 is equal to n2 plus 1. For n1 odd we follow this definition. For n2 even we follow this definition. So n1 minus n2 is equal to 2. Hence for fn1 not equal to fn2, we have n1 is not equal to n2. Any type of problem you are feeling, then remove this third step. Now for on 2, let n is odd. If n is odd, fn is equal to n minus 1. Earlier fn is equal to n minus 1 for on 2. Write fn is equal to y is equal to n minus 1, so n minus 1 is equal to y, so n is equal to y plus 1 for on 2. Fn is equal to n minus 1, y is equal to n minus 1, so n minus 1 is equal to y, so n is equal to y plus 1 first. Likewise for on 2, n is even, fn is equal to n plus 1, write it y is equal to n plus 1, or n is equal to y minus 1. Now for on 2, we prove that for on 2 we have to show that fx is equal to y or fn is equal to y. LHS, fn is equal to fy plus 1, so this is y plus 1 minus 1, 1 cancelled, so this is equal to y. Hence on 2. Now here for on 2 we should prove fx is equal to y or fn is equal to y. LHS, fn is equal to, put the value of n, y minus 1. So again follow the definition of even case, y minus 1 plus 1, again y. Hence on 2. Now f inverse y, this will give f inverse y. If n is equal to y plus 1, f inverse y is equal to this. If n is equal to y minus 1, f inverse y is equal to this over. We have to show that f is many one function, many one, never invertible. F is a function from n to n and fn is equal to this if n is odd, this if n is even. So that f is many one is never invertible. Answer: since fn is equal to n plus 1 by 2 for n odd, so put n is equal to 1. N is equal to 1, n 1 is odd. So we follow this definition, 1 plus 1 by 2, 1. So since fn is equal to n by 2 for even, this is for odd, this is for even. If n is equal to 2, f2 is equal to 2 by 2 is equal to 1. So clearly many 1, because 1 is going to 1, 2 is going to 1, 1 is going to 1, 2 is going to 1. This 1 goes to 1, this 2 goes to 1. Now for on 2, let n is odd. So fn is equal to n plus 1 by 2, written earlier, fn is equal to n plus 1 by 2, or fx is equal to x plus 1 by 2. You can write y is equal to x plus 1 by 2, cross multiply x plus 1 is equal to 2y, so x is equal to 2y minus 1, to show fx is equal to y. Likewise for on 2, n is even, so fn is equal to n by 2, or you can write fx is equal to x by 2, so y is equal to x by 2, x is equal to 2y. Here we have to show fx is equal to y. Now LHS, if fx starting from fx LHS, f of this, now this is for odd in odd, kuch plus 1 by 2, so this kuch plus 1 by 2 to 2 cancelled. This is the definition. So cancelled, y proved. Likewise fx is equal to 2y, so 2y by 2, so f is on 2. And since this is many ones, so never invertible. Thank you very much.